Hello everyone, welcome to my channel. I am Divya, alumna of Osmania University, pharma mentor for GPAT, PGECET, NIPER or any pharmacy entrance exams. Today I am here with a high-yield topic of pharmacognosy, that is alkaloids. In alkaloids, we'll see the classifications, introduction, properties, identification test, and here in my channel you should be noted always that these all sessions come with memory hacks and mnemonics to remember until your exam time. So, not wasting much of our time, let's begin with alkaloids introduction. In alkaloids introduction, we generally see the definition of alkaloids, which is very important to point to be noted. These in definition can be remembered in three important points, that is naturally occurring alkaloids means these are naturally occurring organic compounds which are known to contain nitrogen in their heterocyclic ring form. So naturally occurring means these directly mean that they are obtained from plant source here, because pharmacognosy deals with those sources which are found in plants. So whenever the definition of alkaloids is asked, we can just say in 3 points, that is naturally occurring organic compounds and containing nitrogen in their heterocyclic form. And coming to the next point, that is the taxonomic occurrence, means where these are generally found. As already mentioned in definition, that these are obtained or found in naturally plants. So the main source is plants, and one point to be noted is these are very rarely found in lower plants. And one exception to be noted in point of view of our exams, that is you take your pharmacy semester exam or any other exam, the exceptions are very important. So here the exceptional is our ergot alkaloids, which are obtained from ergot fungi. Earlier, these are found in flowering plants only, angiosperms, especially the dicots here. Lower, very less in monocots. Very less number will be shown in monocots. And coming to the next important point, that is about the next important content of alkaloids here. These are found in flowering plants only, angiosperms, especially the dicots here. Lower, very less in monocots. Very less number will be shown in monocots. And coming to the next important point, that is about the next important content of alkaloids is distribution of alkaloids, where these alkaloids are in generally found. So these, as mentioned, are found in higher yielding plants or flowering plants, we can say higher plants or flowering plants. And the most important or well-known families which are known to contain these alkaloids are Papaveraceae, Solanaceae, Rubiaceae, and Apocynaceae. And here you can remember a simple mnemonic, I could say, that is PARS, PARS. Very simple mnemonic where these alkaloids are most commonly found. Parts. Parts where P stands for Papaveraceae, A for Apocynaceae, R for Rubiaceae, and S for Solanaceae. So these are the major four families of plants which are known to contain alkaloids in higher concentrations in them. And coming to the main exceptions, that is which are devoid of or free from these alkaloids, are two major families here, that is our Rosaceae and Labitae. So these are the two major families which are known to be devoid of or free from alkaloids. Okay, these are the examination point of view. So only the important points are being discussed in our session of videos. And coming to the next important point, that is the function. What is the function of these alkaloids in plants? You need to know. In general, these are all defensive in nature, because of presence of nitrogen, they act as defensive mechanisms in plants. And another important function is detoxification in plants as a source of nitrogen and source of energy also for plants. So these are the major functions along with their main function, that is growth regulation. Along with growth regulation, these are known to exhibit these functions, that is defensive, detoxification, source of nitrogen, source of energy, and not but not least, last but not least, that is our growth regulating. Okay, so this is about the basic introduction of alkaloids. And coming to the another important, very important points or concept of alkaloids. The main important one is our physical and chemical properties. As we have seen in glycosides, here also physical and chemical properties play a major role. Coming to the physical properties of alkaloids, here these generally exist as colorless. These are colorless in nature, that is their existence, that is we call it as state. In which state they are found? Generally, these alkaloids are found as colorless crystalline solids. Okay, this is the maximum nature of all the alkaloids. Along with, they are known to exhibit, when they are crystalline in nature, they are known to exhibit the melting points. Okay, they have their specific or distinct melting points. And coming to the third important point, that is the first two are the common points of all the alkaloids. And coming to the next point, that is the exception points, which are important in point of view of our exams majorly, that is emitting here, exception and emitting. Emitting is known to exhibit the nature of amorphous alkaloid nature. That is, when all the alkaloids are crystalline in nature, these are known to exhibit amorphous nature. And another important exception here is nicotine, which is known to be a liquid in nature. Okay, it is not a solid in state, but it is liquid in state. And another example is pilocarpine, which is a non-volatile, again liquid. So these are the three important exceptions of our alkaloids. That is, these are, first one is emitting, which is known to exhibit its amorphous nature. Along with that, the other two examples are liquids. Liquids example is volatile liquid nicotine and non-volatile liquid is pilocarpine. Coming to the next one, that is the color. Another physical property here is color, and majority of them are colorless as mentioned in the state. These are colorless crystalline solids. And another important point here is our exceptions. Exam means exceptions are very important here. Here, these exception is that berberine is known to exhibit yellow color, which is known to show, the alkaloid berberine is known to show yellow color, and sanguarine, which is known to sanguarine, is known to exhibit the orange color. So these are the two exception points you need to remember in point of view of our exams. Any competitive exam or any pharmacy entrance exam you take, or semester exam MCQs also, these are very very important points to be noted. And coming to the solubility, another physical property you need to make a note of, that is the solubility nature of these alkaloids. Coming to the solubility here, these are two kinds. That is one which are freely available as bases, free bases we call them, and second one as alkaloid salts. So these are the two solubility properties you need to make into consideration or make a note of. So coming to the first one, that is the free bases here, generally soluble in organic solvents. Here all the free bases are soluble in organic solvents. Organic solvents best examples are chloroform and ether here. But these free bases are insoluble or very sparingly soluble in water. So this is one of the point to be noted in case of these free bases of alkaloids, that is they are sparingly or most of the times insoluble in water. And coming to the next one, as a salts, when they are available as salts, these are they exhibit generally the opposite, the quite opposite nature, that is they are typically soluble in water and alcohol. Here you need to know, you need to remember these main points, that is when free bases they are insoluble, whereas as a salts these are readily soluble in water and alcohol, but insoluble in non-polar organic solvents. Non-polar means you already know that which do not contain water in them. No polarity. Okay, non-polar in nature. And coming to the most important, another most important points, or we can say the content of our alkaloids topic, is the chemical properties here. In chemical properties, the major point we will talk about here is the basicity, because these are known to contain, from the definition itself it indicates that these are alkali like, means they are known to exhibit the basic nature. So how do they exhibit this basic nature of alkaloids? Major, we have already mentioned this point, that is they are known to contain nitrogen in them, because of which they exhibit the basic property or alkali like property. And this nitrogen is found as in the heterocyclic ring. Heterocyclic ring is nothing but when one of the carbons in the aromatic compounds is replaced either by nitrogen, sulfur or oxygen, they are called as heterocyclic compounds. So here it is the nitrogen which is present as heterocyclic ring in them, and is known to exhibit the alkali like or basic properties of these alkaloids. And coming to the another important point, though they are basic, they act as in generally as weak bases that form water soluble salts. As we have seen in the physical properties, their solubility, they are freely soluble in water. So water soluble salts with organic or inorganic acids, they form this water soluble salts. So organic, we use this oxalic or tartaric, and inorganic we use the HCl, that is hydrochloric acid or sulfuric acid. So this is about the another important chemical the major important chemical property of alkaloids. And coming to the another chemical property is optical activity. We all know that optical activity is directly connected or linked to the chemical nature of the compound. That is when the compound is known to contain chirality, that is when carbon is known to exhibit chiral nature, when it is being substituted with four different functional groups, it is known to exhibit chirality and known to have the optical activity. And here optical active compounds are generally of two types, that is either L isomers or D isomers. L, that is L-ephedrine we take, generally these are known to exhibit or the have the pharmacological activity, whereas compared to D isomers, these are generally inactive in nature or known to exhibit sometimes the side effects. So these are the important points need to be considered when we talk about the optical activity of alkaloids here. So that is L isomers are more active pharmacologically compared to D isomers. So L-ephedrine compared to is more pharmacological exhibit, is known to exhibit pharmacological activity compared to the D isomer here. And coming to the another specific chemical property here is precipitation reactions. Because of our basic nature or nitrogenous nature, these are known to be insoluble colored complexes, form the insoluble colored complexes with metal iodides, and these are used as our test of identification of alkaloids that we are going to discuss in some time. And coming to the next chemical property here is the stability of alkaloids. All these alkaloids are known to get decomposed when they are exposed to heat. So when they are exposed to heat, they are decomposed Exceptions are our strychnine and caffeine. Caffeine are these two are exceptions and which are very important in point of view of our examinations. And coming to the most important part, that is the classification of alkaloids. When we talk about the classification of alkaloids, here we come across four different kinds of classifications, that is our taxonomical classification, biosynthetic classification, chemical classification, and pharmacological classification. Here taxonomic classification is nothing but from the source from which they are formed, that is on the basis of the plant source or on the basis of their family, these are classified. This is not much preferred. And coming to the next one is our biosynthetic, and third one is our chemical classification. Fourth one is pharmacological classification, that is on the basis of their pharmacological activity they exhibit. Either they act as antibacterial or anti-anginals or antimicrobials in on that basis, or antispasmodics. On the basis of these are classified. This is also not given the much importance, that is all these together can be discussed in our chemical classifications and biosynthetic classification. So here in exam point of view, these two, the biosynthetic and the chemical classifications, are very important, and I'm going to discuss them in detail now, with along with quick memory hacks of this classification, because in exam point of view, these two types of classifications are very important, whether you take your semester exams or any other entrance exams like GPAT, PGCET or NIPER or any other UPSC exams also. These biosynthetic classification as well as our chemical classification are the most important one. And here, very simple biosynthetic classification. When we talk about biosynthetic classification, that is the main source from which they are being derived, the biosynthesis. So here these are classified on the biosynthetic nature into three types. That is, the first one is called as true alkaloids, second one is our proto alkaloids, also called as amino alkaloids, and third one is pseudo alkaloids. So coming to the true alkaloids, means these are derived from amino acids which are highly reactive in nature, and these are known to be true alkaloids. So these are known to complete with that of our definition, that is these are known to contain nitrogen as in their heterocyclic nature, that is as a part of their heterocyclic ring the nitrogen is present, hence the name the true alkaloids. And coming to the best examples, here are morphine, quinine, and atropine. These are the best examples of our true alkaloids. And when we talk about the proto alkaloids, these are also called as amino alkaloids. So other names are very very important. Proto alkaloid is also called as amino alkaloid here, and these are derived from amino acids. These are also derived from amino acids, but the important point to be noted here is these do not contain nitrogen as heterocyclic in nature. That is, the heterocycling ring don't contain the nitrogen. They don't have the nitrogen in their ring. So, and the best examples here are our ephedrine, mesaclin, and colchicine. So, these are the three major examples of our proto alkaloids or amino alkaloids here. And coming to the third one, that is our pseudo alkaloids. Here, you can remember these biosynthetic classification as TPP, or your wish, or PTP. Okay, either of the ways we can remember the biosynthetic classification of alkaloids. That is, TPP would be more better because it shows the nature also and easy to remember the examples here. Because the true alkaloids, the best examples are morphine, quinine, and these are more commonly repeated atropine. And protoalkaloids, which is also known as amino alkaloids, though they are derived from amino acids, but the major difference is that They do not have nitrogen in their heterocyclic ring. Coming to the pseudo-alkalides, pseudo from the name itself indicates that it is not a true alkaloid. That is, they are not derived from amino acid. But the important nature why they are considered under alkaloids is that they contain nitrogen in their heterocyclic ring and share the structural characteristics along same as the true alkaloids. And the best examples here are caffeine, theobromine derived from purine alkaloids and